Hey there, in this video I want to talk about solving simultaneous equations, specifically linear equations. So this would be equations that look like, say, 4x plus y plus 2z equals 1, and 2x plus 2y plus z equals 0, and x plus 4y plus z equals 2. So that would be three simultaneous equations with three unknowns. And we can solve those, by hand. But we don't want to do it by hand. We want to make the computer do it for us. And so the trick we're going to employ here is we're going to use linear algebra and a technique called Gaussian elimination. We're going to run through Gaussian elimination for the three equations I wrote down by hand just to see and get a good feel for how it works. But then we want to carry that knowledge over to how could we make this generic and solve for any sets of equations. So the key here is to write this in the form matrix A times vector x equals vector v. So in other words, the coefficients that I wrote down will appear in the matrix A. So that would be 4, 1, 2, 2, 2, 1, 1, 4, 1. And then the vector x would be the unknowns x, y, z. And if we multiplied those two matrices, that would exactly be the left-hand side of the equations up above. And then the right-hand side will be another column vector here, 1, 0, 2. So we want to solve this matrix equation, and there are several ways to solve matrix equations. We're going to use Gaussian elimination, and the nice thing about that is it's very systematic and it's also really generic. We'd always follow the same steps no matter what matrix we have. So we're going to run through a series of simplifications. At the end of all of this, I want to create a new matrix A that has ones down the diagonal, zeros down here, and then some numbers here. Times x, y, z equals some d, e, f over here on the right, and then that form is called triangular. Specifically, this would be upper triangular, and it's easy to solve because we could just read across working from bottom to top. Okay, so that's our plan here. And to start out with, we're going to begin at the top, and I want to make it so that row 1 starts with 1, and all the other rows start with 0. Okay, so step 1 here, what I want is first row starts with 1, the other rows start with 0. So to make that happen, I can start out by dividing the first row by 4. As the number 4 goes up here. And if I divide that whole row by 4, then I'm going to make it start with 0. Remember, with a matrix equation, really any kind of equation, whatever I do to the left-hand side, I also have to do to the right-hand side. So as I divide my first row, 4 divided by 4 is 1, 1 divided by 4 is a quarter, 2 divided by 4 is 1/2. I'm going to leave the x alone, because you think about like working with an equation, your x, y, z don't get divided by 4. It's the coefficients that get divided by 4. But on the right-hand side, I had a 1. But if I take 1 and divide by 4, I'm going to get 1/4. And I just realized this is kind of sloppy up there. Okay, so 1/4. Now the other rows are left completely alone. So it's still 2, 2, 1, y, and 0, and it's still 1, 4, 1, z, and 2. We haven't changed those yet. The next thing I want to do is some subtractions. Let's just continue that over here. So I want to subtract 2 times the first row from the second. And in doing so, I'm going to end up with a 0 to begin the second row. And I want to do the same sort of thing to the third row, except in that case, I want to get rid of a 1 down here. So to make that happen, I need to divide by 1 times the first row. So my first row hasn't changed. 1, 1/4, 1/2. The second row is going to be divided by 2 times the first row, or I'm going to subtract 2 times the first row. So I'm going to take 2 minus 2 times 1 is 0. That's the whole point, is to get that 0. Then I'm going to take 2 minus 2 times a quarter, so that's 2 minus 1/2, or 3/2. And then I want to take 1 minus 2 times 1/2, so that's 1 minus 1 is 0. for my third row, I'm going to take 1 times the first row and subtract it. So 1 minus 1 is 0. Again, that was the whole point, was to get that 0. 4 minus a quarter is 3 3/4. That would be 15 quarters. And 1 minus a half is a half. Leave x, y, z alone. And then on the right-hand side, we still have a quarter to begin with. We haven't changed that. I want to take, what did we have before? We had a 0 there, minus, yeah, we have a 0 right here. And I want to subtract 2 times a quarter. So a 0 minus a half is negative 1/2. And then we have a 2 minus a quarter. So 2 minus a quarter is going to be a total of 7/4. So we've got the first row looking like we want, and we're working on the second and third rows. So now what I'd want is I want this element in here to be equal to 1. So I want second row to start with 0, 1, and the other rows, the other row, the third one's the only one left, I want that to start with 0, 0. So first thing I'm going to do is divide the second row by 3/2. So if I write down my new matrix equation, I'm going to have a 0. 3/2 divided by 3/2 is 1. 0 divided by anything is 0. I haven't touched the third row yet. And then on the right-hand side, we have the 1/4. I want to take negative 1/2 and divide by 3/2. That's going to give me a negative 1/3, and the 7/4 are alone, or are left alone. Next thing I want to do is I want to do some subtraction. I want to make this here a 0. So I need to subtract 15/4 times the second row. And I want to do that subtraction from the third row. So I have 1, 1/4, 1/2, 0, 1, 0, 0, 1. Okay, now what are we going to do here? We're going to take 15/4 times 0 is 0. 0 subtracted from 1/2 is still 1/2. Got x, y, z, and then we have to do this to the right-hand side as well. We still have a quarter, still have negative 1/3. Now this last one, this one's a little bit ugly. We want to take 7/4, and then I want to subtract 15/4 times negative 1/3. Okay, and if we do that, we're going to end up getting 3. And then the final step in the elimination here is I want the very last row here to be in the form 0, 1. Actually, this was already supposed to be a 0. I want this last number here to be a 1. So to do that, I need to divide third row. Well, let's just be careful here. What I want is my third row to be 0, 0, 1. And so I can make that happen with a division. So I divide the third row by 1/2. And since I'm running out of space, let's just do that in place here. I'll just switch colors to make it a little bit more obvious. I'm going to take a 1/2, divide by 1/2, that gives me a 1. And then 3 divided by 1/2 gives me a 6. Okay, so that's going to be my final simplified matrix. And it's now in a form called upper triangular. So what I can do is I can read across that matrix bottom to top. So for example, if I read here across this bottom row, it tells me that 0x plus 0y plus z equals 6. That's giving me part of my solution here. It's telling me that z equals 6. If I read across the middle row, 0x plus y plus 0z, so y equals negative 1/3. And then the top row says x plus 1/4 y plus 1/2 z is equal to 1/4. We can plug in the values for y and z that we just found, and we're going to end up with x is equal to -8/3. Okay, and so we have solved our problem. We found x, y, and z by going through this process called Gaussian elimination. Now, the great thing here is that we only did two kinds of operations. Those two operations are divisions. So we divide a row by whatever it starts with, whatever non-zero thing it starts with. And the second thing we can do are subtractions, subtracting multiples of a row from the other rows. And that's it. That's the only thing we did. And so we can program a computer to do that, and that's what we're going to do next. So over here in the notebook, I want to start coding a solver that'll do Gaussian elimination for us. I'm going to start the process, and then you'll continue the process. So let's call our function solve 3×3. It'll specifically be coded to do 3×3 Gaussian elimination. And we're going to give it matrix A and vector V. And those will be represented probably by numpy arrays. We'll assume that they'll be numpy arrays. All right, so then in our function, we need to do a few things. First thing we need to do is make sure we make copies of A and V. We're going to start working on this row by row, element by element, and if you do that in Python without making a copy, you're going to change the original array A and V, and that might make your code break at some later point. So what we're going to do here in our code is we're going to make a copy of A and a copy of V so that we don't have to worry about breaking the originals, and that's done using the method called copy. So for A and V, we're going to replace them with a copy of A and a copy of V. So here I'm just doing multiple assignment just so it takes a single line. I could do it on 2 lines without changing anything. And basically we take the original value A that was passed to this and we copy all the data into a new name A. And A is now a local variable in my function. It won't affect anything on the outside. Without this line, the code is going to work, but if you test A and V after running this function, you'll find that you'll have changed them. Okay, so that would be the first thing we need to do. Next thing we need to do is the division step. So we want to divide the first row by whatever the first thing in A was, A00, or like in Python notation, A00. And then we want to do some subtractions. So we want to subtract a multiple of A from rows 2 and 3, or I guess rows 1 and 2. We're going to be 0 indexed here after all. So we want to subtract let's see what that would be. That would be A10 is what we'd want to subtract. Or that would be our multiple, right? We want to subtract A10 times A0 from the row A1. And then we want to do the same kind of thing for row 2, which is the third row in the actual matrix. So we would subtract A20 times A0 from A2. Okay, and the comment here is actually really similar looking to what the code is, with the important distinction that we also have to change V if we change A. So let's just write out the A part here, and then we'll do the V part. So the new first row in my array is going to be equal to the old first row, but dividing it by A00. Okay, simple enough. But we also have to do the same thing to V. And it's tempting to write V0, so the new V0 is equal to the old V0 divided by A00. However, this is a bug in the program. If we look here, A00, we have already changed A by the time we run this next line of code. So we'd be dividing by the wrong value. We wanted to divide by the original value in A. And so our solution here would be to come back up here and do it on the same line. So if we do this code here on the same line, I'm going to cut and paste, then that entire line of code happens effectively simultaneously. Not literally simultaneously, but it'll use the old value here for A. So if I say A and V are going to be equal here, it takes the old value of A for both of these parts, and it doesn't update A until after it's done that part of the calculation. Basically, Python evaluates an equals sign here from right to left. So as it goes, it's going to use the old value of A, old value of A, and it's not until it's done, it's like, oh, I better change what A was. So you'll be safe if you do it this way. And this isn't the only place in this class where we're going to see this happen. So if you want to change two values, let's call it simultaneously, at least conceptually simultaneously, you can use this multiple assignment here in tuple unpacking to make it all happen at once. All right, so now our next line here, we want to take the row 1, that'd be the middle row of our matrix, and I want to replace it with A1 minus A1, 0 times A0. But we want to do the same thing to V as well. So we want to come over here, add a little bit. So the second statement, I want to make V1, put a comma over here, equal to the original V1 minus A1, 0 times A0. Oh, sorry, times V0. So we're subtracting here multiples of A times, in the first case, times A, or in here, times V. And that should be really similar to the code we're going to call here for the last part, except we're going to change the 1s to 2s. So anywhere you see a 1 here, it's just going to become a 2. And altogether, that would be the first step in Gaussian elimination. We'd go through steps 2 and 3, basically following the same pattern. Careful with your indices. And then when you're done, you'll need to solve for x, y, z, exploiting the fact that you have a triangular matrix. So you need a little bit of code to, you'd actually do this in the reverse order. You find z first, then y, then x. So you'd write a little bit of code that does that for you, and then you could return the values.